Okay, ready to start? All right, so quick introduction. I am Tom Dyer. I work at a company called InterSystems. You guys were at the opening presentation, and I gave a little commercial for the company there. So I'm a product manager, which means I get to talk to people about our product, which I will do right now. And also I have a background in bioinformatics and data science and things like that. So happy to talk to anybody about any of these topics. So I'm just going to quick outline. I'm going to talk about some of the challenges with using generative AI. Talk a little bit about embeddings. How many people know what embeddings are? Okay. How many people know what retrieval augmented generation is? Okay, so I'm going to talk about these concepts a bit. And then our product, which is a database, essentially. And we've added vector searching to it, so it's now a vector database as well as SQL, documents, and all other things. So our database is really flexible, and it's a really good thing to kind of build your applications on. So as you all know, it takes a lot of hardware to train a big model, and that's a challenge with generative AI. There's definitely kind of an access issue. It's not available to all companies to train a big foundation model. But local LLMs are getting better and better, as you've seen. Llama 3, you'll be able to run those locally. You could run things on iPhones now. So it's getting really cool from that perspective. But they hallucinate because they're basically trained to hallucinate. That's what they do. They're not really thinking like we think. And they just don't really understand. So that can be a problem with high stakes applications, like healthcare that we deal with in our company. We also have 20%, 25, 30%, maybe more of the world's equity trades clear on our technology. So all the finance companies that we talk to, in fact, this is interesting. We were talking about, I was asking one of the product managers in finance stuff that we make an application for traders and asset managers. And I'm like, okay, I want to put this generative AI in the product. And he's like, hold on. He just got a call from our biggest customer that just was he got a call saying, you're going to get an email. I need you to answer it right away. Email comes up and it's like, do you attest that you are not using generative AI in any of your software? Yes or no? Click this button. It was like a legal document that we had to sign saying that we do not use generative AI. So finance companies, big banks, they're very scared about it still. And that's because it's not always right. And the bias depends on what the training data is. So you may not get correct answers due to just bad training data. And once you say one little thing incorrectly, it can totally throw off the response. So there's a lot of challenges. And one of the ways to get around it is to use retrieval augmented generation, and embeddings and vector search is a big part of that. So, the concept of embeddings is that, well, ever since Word2Vec, which was basically 2009, maybe something like that, when the actual paper came out, when statistical language models were first able to kind of understand the meanings, different meanings of words, depending on the sentence, depending on words that are around them. And ever since then, the models have gotten bigger and bigger and more complex embedding spaces, which means that it can understand more and more nuances of language. Like in this case, if you're trying to think of vectors, they're just like a point in space. Usually it's many hundreds of dimensions, so you can't really visualize it very well, but you can think of it as points in three-dimensional space, like in this picture. And of course, you can have animals there that are like on the left side. And then fruits and vegetables will be in a different part of space because every concept is in a different part of space or a different location. And then similar things should be close to each other. And that's really good because They are just big, long dimensional arrays. They're easy to handle within, like, within computers, right? And they capture the semantics, so that's really good for doing search. They're compact. So it's actually kind of funny. You think, well, 300 dimensions or 1,500 or even 5,000 dimensions sounds like not very compact. But when they first started making these language models and trying to use language with computers, and the actual number of dimensions was like as long as how many words are in your dictionary. So it would be hundreds of thousands or thousands and thousands of dimensions. And those would then be either 0 or 1, depending on if the word was in the sentence. So once you make these embedding vectors in these language models, they get compacted. So, and the good thing about using these points in space is now when you want to look for something similar or a similar concept, you have some search term, all you have to do is nearest neighbors. You're just looking within a geometrical area, and maybe a very complex geometric space, but it's still just nearest neighbor search. And then, of course, doing this whole process requires taking your unstructured data and making an index about it, managing all that data, combining it with other data, depends on what you have. So what's the basic process for retrieval augmented generation? Some of you are very familiar with this, but basically retrieval augmented generation is just a method, and it's a kind of a family of methods of how you use your data with a large language model. Because large language models, well, they were trained a long time ago. The cutoff for GPT-4 was somewhere in last year, right? So maybe the newest models are a little bit more up to date, but it took so long to train them that they can't retrain them on a dime. So if you need to use like fresh data, you're going to have to use your data or get it from the internet. The large language model in this case is up in the upper right. We're not talking about it quite yet. First, you have to start with your documents. And the first part of indexing is chunking them. So you take each document, you turn it into a number of chunks that are basically the size of kind of the meaning that you want to get, maybe about a sentence worth of data. Then you have to vectorize that. Well, what does that mean? You run it through an embedding model. It's a large language model, but they're compact. They're smaller than kind of ChatGPT, and they only output these vectors, these long strings of numbers that are those points in space that I mentioned. And then you put those in your vector database. You do that for all the chunks. They go into their different parts of this space, this latent embedding space. Now when you have a query and you say, for example, where do I park, right? And maybe all of this information was from like your internet, it might have information about where to park, like at your hospital, for example. Well, to search that, you turn that into a vector. And then you just go in and look for similar vectors. You get those out, you go back to the chunks, you get the original chunks, and now you make your prompt that you actually go to the large language model with. You say, answer the original question, only use this context, use this information that I gave you, not something you think you know, and then answer the question. Then that actually goes to the large language model and you get your answer. That's all it is. There's a lot of complexity that you can add to it, the way that you actually make these vectors counts. There's a lot of parameters, like how big are these chunks, all that kind of thing. Any questions on this so far? Yes?
Once you have the embedded vector,
yeah.
When you want to go back to the original sentence,
yeah.
Well,
it's like there has to be like an index, which has a relationship. So the way that it works in our system is that, usually use a vector database. And in our case, we're like a vector database, but it turns out to just use SQL to do that. We have a table. Yes?
Well, probably it's kind of my question or something, but like, so what, it depends on the model, probably.
Yeah.
But, like, I have like, very specific semantics of like tags. Like for example, I'm saying something and then I indicate what I just said.
Yeah.
The embedding then just be representative of like the first thing. So like I say A, then I say no A. You know, like I
Yeah. That it's logically inconsistent.
things like that.
Uh-huh.
Embeddings, like they would probably just like misrepresent the text or represent just one part, etc. Like, so
It might choose. Yeah, it depends on the model, right? Yeah, and like a company just released an embedding model that they said does better. These things happen all the time where there's new ones, and you could fine tune. So if you had some particular problematic kind of sentences, you could actually make your own data set to fine tune it.
how well does this scale with the size of the task? You know, because like it's a matter of entity. Yeah,
Yep. Yeah, a lot of things. So one of the complexities that I went over is there's a method called Raptor, R-A-P-T-O-R, that came out, where it's basically making embeddings at different levels of granularity for one document. Does sentence level, then makes different vectors for each, like couple sentences, then makes a vector for paragraph, and then the whole document. And so that allows it to summarize more and more data and then switch back and forth between those levels.
Smallest granularity and then combine them like for somebody.
I can't remember. You have to look it up. But it's just one of these methods. You had a question? Oh, wait, hold on. Okay. For which one? For vector searching. Well, for similarity search, we have a couple functions in our database, so like dot product or cosine similarity to use the semantic search, basically to search over your embedding vectors. But it's in SQL, so there's one way that you could say hybrid is that you can make a SQL query that works on the metadata and filters it down to like a number of rows, and then within that, do the similarity search. So that would be kind of hybrid search, but actually hybrid search in the world of vector databases actually means combining keyword search with semantic search. We don't have the keyword search within our database, like BM25 is like the most like common algorithm. We don't have that, but someone could implement it pretty easily. Yes?
You said about using the words as sentence. So if I say I want an apple, an apple.
Yeah.
Identify these two apples.
That's the kind of thing that they're really good at. Because it's picking up on that little bit of that an apple, and you didn't say phone, so it thinks that it's the other. It knows that based on other sentences that that's probably the other sense of the word apple.
Question on top of that. How is it better to search? I want an apple or just the labels apple or apple?
Well, I think in that case, it just shows exactly why you want the context, because those are totally different things. So if you want them to just show up the same, then just use regular keyword search. But if you want that context, you do that differently. So then within our, this is just kind of this low-level kind of SQL syntax type of thing. And there you can kind of see how you can combine different things within a SQL query, where you just have vector.product is a function, and then you sort on that. Very simple. Don't have to worry about that. We're also going to we're going to make it easier. So right now, still you have to like really use the vectors, but for a database, it would be nice if you could just say, I have a table and I want to search over it, and we're going to do that eventually. So it all doesn't really make any sense. Okay, go ahead.
Yeah, you showed the query of the similarity. I was wondering, is it semantic similarity or how is it similarity?
It's cosine. It's vector. It's a dot product or cosine over the embeddings, which makes it semantic. Because the embeddings have the semantics embedded within them. But it does depend on what kind of model you use to create these vectors. Because you could also have data that's like images. They can have embedding models that make vectors, and you could use this to search over images. So it's really general. It depends on the model that makes the embeddings. Yes?
So let's say we have a query.
Yeah.
We perform the nearest neighbors.
Yes.
How do we know if whatever we retrieve really answers the question, or is it noise? How do we test it?
You have to test. All these things are kind of testing, you know, because there's nothing that knows the true meaning. One of the things you can do that's interesting though is you can like run your output from one model into another model and say, does this make sense? So you could automate that to some extent by using another language model to like detect some problems. Yes?
Hi. So the challenge reads best use of GenAI using your IRIS Vector Search.
Yes.
But if we don't really emphasize GenAI, we just reuse some of the existing technology.
That's all good.
That's
Yes.
Our
Innovate, it's more like, most use cases are going to be generative AI.
All right.
But I was going to talk, I may, if I get to it, I don't know if I'll have time. But anyways, but I was going to just go through some of the other things that we have. It doesn't really help to have this great technology if you can't get to it. So one of the things that we've done is just added LangChain and Llama Index integrations that just work right out of the box. And so within within this repo, it has all the stuff you need to get started. And really what you'll do with our database, is spin up a Docker image. We'll eventually have a cloud service. Almost had it ready for this event, but it didn't happen. So, sorry. Anyways, but these are really easy to use, and they'll get you going. So the other thing so this is a challenge. That's the QR code that I showed before. If you missed it, there you got it. I'll give a couple seconds. So then one thing I wanted to talk about a little bit was that to your question, whoever was about the other vectors, we're actually working with a biotech company that's using our vector search to take not only DNA models, but protein language models, a bunch of different foundation models for different types of bioinformatics work, and just storing each one of those embeddings as like a column in tables. So then they can fuse all this data. And that's like omics data, clinical data, and put that all together. They have their own foundation model that captures all that information. They can go back and forth between all those embeddings in a graph database that has a very structured information about all the things with proteins. And this just shows some output of the kind of thing they do in their workbench, where this is a three-dimensional representation of embeddings. But you can see like a little cluster of like these antibodies that happen to cluster together, and then they can find that kind of match as well with their searching and using this cosine similarity to search. So it's a real-world application using this using our vector search, and I hope to see some very interesting kinds of things come from you guys. So I did have I can actually maybe flip to my demo and show these things actually working. Let me see. I think that's it. Yeah. Is that? It's hard to see. No? Oh, on the screen at the streaming? Should be, but I guess it. Oh, I think that's where. Is it showing? Okay. It's not all that exciting. Yeah, it doesn't matter. They won't see it online, but. Yep. So really, this is just all Python code that runs pretty well. We're gonna look at this essay. So we have one big essay of text, and we want to ask questions on this essay. So we've got this llama index is really good for RAG stuff, and just a couple imports here, and then this is the piece that's the IRIS Vector Store, which just fronts our database. Then you put in your OpenAI key. If you don't have an OpenAI account, a ChatGPT account, I can give API keys for this event. So just come up to me, and I will give you one. So once you put that in, at least for this demo, of course you can use local models. You can use whatever setup you want. This just happens to just go to OpenAI. And then you just load the data. That runs quickly. Connect to the database. Make a vector store. Of course, I'd already run this. But then when you go over that, this is the main thing, that it just went over that document and made the vectors using the OpenAI embedding. And then once that's done, you can chat with your data. It's that simple. So actually, I should clear this and show that it's actually doing it. Yep. So that was, what did the author do? AI was in the air. Oh, that was it. Okay, wait a minute. Hold on. I didn't run that. That actually ran. And that ran. So that's as simple as it gets. So once you have that running, then you can put in your own data, change it up, work on it, whatever. So I think that's pretty good. Any other questions? Oh.
Hey, so while there is a rule that says you can't tell us the reward, according to your
Yeah.
understanding, do you think the reward is good or good for
I think they're good. It's good for students and it's good. There's one of them that I want. So I'm hoping maybe I can act like I'm a student. They're good. I mean, we've had really good things in the past, but we can't tell you about this stuff. Not allowed to. You have to do it for your own desire to learn. That's why they don't want us to tell about the prizes. You can't be swayed by these capitalist pigs that are trying to entice you to do something that you wouldn't normally do. Okay. All right, thanks very much. Good luck.